Next, connected to momentum is something called impulse. So if you hit a ball with a bat, or if you hit a golf ball, there's this certain time where there's this dramatic force on one object, and that's called impulse. So it starts off with the original force equation. And I'm going to rewrite this a little bit so that we can kind of see where the impulse equation comes from. We know that acceleration is actually change in velocity over the change in time. And so I'm going to write it like this. I'm going to write v2 minus v1 all over change in time. And so that's basically change in velocity over the change in time. Now I'm going to multiply by the change in time on both sides. So force times change in time is the same as, and I'm also going to distribute my m to the top here. So this would be mv2 minus mv1. Okay, now you may think, well, m times v is momentum, right? This is the final momentum, and then this is the initial momentum. So what it really is saying here, this is change in momentum on the right side. So force times change in time is your change in momentum, which is your impulse. So when I say impulse, this is changing the momentum of something really quickly. Alright, so here's an example. A 46-gram golf ball is struck and flies at a speed of 40 meters per second. So find the impulse and then find the work done. Alright. So A, we just got an equation here. Force times change in t equals the change in momentum. Okay. Now, you could also think, since we're just looking for impulse, we could just look at the change in momentum. And another way to write this that can sometimes be useful is this. So we're going to take the momentum at the very beginning and compare it to the momentum at the very end. Alright. Now, if you think about it, at the very beginning, the momentum was 0 because we had 0 velocity. So I'm going to get rid of this. And our impulse is actually just going to be how much momentum it has after it's been struck. So that's going to be 0.046 kilograms times the velocity. The final velocity is 40 meters per second. Okay? And so if you work this out, you calculate it, it's 1.84 kilograms meters per second. That is the amount of momentum. Sorry, it's the impulse. That's the total change in its momentum. Which it makes sense because this is a small object, so the change in momentum is not going to be too terribly big. Now let's think about find the work done. So we have to go back to one equation that we had before that we can't forget about. Work is actually the change in kinetic energy. And so this is going to be related. Remember that change in kinetic energy is the kinetic energy of the final minus the kinetic energy of the initial. And just like what we had in part A, we're going to cancel this out. There was no speed at the beginning. And so we're just going to look at the kinetic energy of the final instant that it was struck away from the golf club. So this would be 1/2 mv squared, which is 1/2 times the mass again, which is 0.046, and then the velocity is 40, but it's going to be squared this time. So we're going to get a much larger number here. We're going to get 36.8 joules. So you could think of this two ways. This is actually the kinetic energy of the ball, but it's also the amount of work that's been done on it. So here's one that you could try. It's an example that you should probably pause the video for and just try on your own, and then you can play it again and check your answer. Now just be careful because this pitch, it's pitched towards the batter, and then the batter hits it back. And so this is going to be a positive speed, this is going to be a negative speed. The velocity is going to be opposite in each direction, so just be careful when you try this. Okay, so here's what we do here. The impulse is change in momentum, so I'm going to think mass times v2 minus mass times v1, or the final momentum minus the initial momentum. And I'm going to do mass, which is 0.145. Now, the final mass is actually going to be negative 50 minus, and then we're going to have 0.145 again, times the initial, which is 45. Okay, now one thing, because I'm a math guy, I could factor out of 0.145 and just do minus 50 minus 45. Because you see there's an m on both of these, so you could just bring that to the front. When you do the calculation, you're going to get negative 13.3 kilogram meters per second, which you could just think of that as positive because that's how much energy or momentum it has. The reason that's negative is because it was hit back, so you could think of it as a positive quantity. Now, if you didn't think of the change in direction, you would be thinking of the difference between 45 and 50, which is only 5 meters per second. But because it's hit back, it's actually going to be a difference of 95 meters per second in both, because it has to make up for the initial pitch, and then it has to be hit back with a certain amount of velocity.